In a reaction related to amidation, we've got lactam formation, which is similar to lactone formation. Now let's take a look at the pattern for that. As it was with lactone formation, the X group is actually going to be part of the same molecule that contains a C double bond O attached to the Y group that ends up leaving. So if we're going to see the same pattern here, what we're going to do is we're going to look for the X group, and the X group is everything minus the hydrogen, but the X group will actually be also everything attached to the C double bond O as well. So here's our X. The Y group is whatever is attached to the C double bond O. As you can see, here's our X group, and here's our YH, or HOH or H2O. Let's take a look at the mechanism. Pretty much the same patterns as we've been seeing before. First step, C double bond O attacks the H plus. The N attacks the C plus. And that's the cyclization step. And leaves a positive charge on the nitrogen. Now again, in the proton transfer step, we're going to be looking to transfer the proton to the leaving group, and the leaving group is the Y group, or the group that was originally attached to the C double bond O. And in this instance, it's this OH here. Oops. So the proton will end up being transferred to that OH. As I said in the past, technically it doesn't matter which OH it gets transferred to, but in the future the Y group and the OH won't always be the same. So it's just safer to go ahead and just transfer it to the Y group. I'll make this bond a little bit more clear. And what's going to happen is we're going to reform the bond between the double bond between the C and the O, and we're going to get rid of the leaving group. And I'll just make that bond a little bit more clear so you can see where the arrow is coming from. The arrow is coming from the bond and not the hydrogen there. There we go, that looks better. And there's our lactam.